We're here tonight looking at the self-driving car model again, and I've done a few things off stream since last week. One second. Last week I was building a model, trying to just get the steering right. I was futzing around with the data. That's done now. The data is officially fussed with. I've got this shrink.py to take a bunch more data in and compress it to get only the data out I need from this deeptribe.io data. So that's super convenient. I don't think this actually changed. I might have mentioned that I had some bad data last time. Well, I went and I grabbed more data from the deeptribe.io just to get more data, about 3 times as much total. And I found more sections that were bad. I might actually show some of these. I probably won't. There was a scene where the car that was driving went like off the side of a cliff and was upside down, but the camera kept rolling, and so it was actually looking at the car that was trying to steer madly. That was not part of the... That was not data that I needed in the model, though. That was not going to add anything to it. So I ripped that out. So I watched all this footage at like 10x speed or something to do that. And I found out I was doing something very wrong. I was not sorting my list of files when I was reading them in, so I wasn't guaranteed you get the same order every time. When I added data in, of course, some new data got interspersed between old data, and things got all out of control. But yes, so we have new data now, and actually, let's flip over there. So this first bit here, this is data that I had before. So the first 10 or so, or 11 data files. And then I grabbed, it looks like another 15 or so here, and I tried to grab from the end to try to get data that looked very different. And I think this is much more urban driving. This driving over here is following one set route, going along sort of a beach. And so that's kind of interesting. And then I saved off the new data. And so the new data set is like 250 megabytes of mainly the images, and you get the speeds and the targets, of course. That's not too fancy. And the other thing that I did off stream, which might be interesting to people, is I decided to rebuild the combined steering and acceleration, or gas pedal, however you want to call it, model that I sort of initially started with. You might recall I had previously tried to do this, and it failed to work. It was always giving me zeros or something terrible. So I think I've gotten around that now. And that I set that training, I tried to train it over the weekend, and then I took a look at it today, and I found out that something was wrong with that model. I learned an important lesson about naming your layers in Keras. If you don't give it a name, it will sort of assign one automatically, but it's not always obvious what that is, and when you're reading in old model weights, it can get confused about what's what. So always name your inputs for the things that you're going to be like putting in or taking out. So this is real input. That is, of course, the speed and acceleration of your car currently. The image input is, of course, what the car can see, and that's just part of the model. We'll get back to that in a second. And the outputs need to be labeled. So you do this name equals steer out. So steer equals this. Again, we have one node on this layer because it's just linear, because we're just predicting a real value. That's all. And we've got regularization on everything now, and the acceleration is gas out, of course, right here. Nothing too fancy. And it's got 3 nodes because we got to compute 3 probabilities, whether you want to go forward, whether you want to stand still, or whether you want to go backwards. Usually you just want to go forward. And the model just says, hey, take our real inputs and spit out our steering and acceleration. We're using this atom optimizer. I think that's the default learning rate anyway. And you can have multiple loss functions. This is something I wasn't sure of in Keras before. I was worried I'd have to make my own custom loss function to handle this, where I've got some categorical output and some real valued output. But you can just pass in a list of loss functions, and it knows, oh, I'll apply this first loss to the first output, the next loss to the next output. You can use a dictionary too, but it was easier just to set that up. And of course you give it your optimizer, and I'm just saying, hey, report both metrics. So I'm going to get the accuracy metric on the steering as well, which is going to be unimportant, and the mean squared error metric on the acceleration as well, which again is not really going to be too informative, but that's okay. That doesn't get used for training, that's just for my own information. And to actually train the model these days, You read in the data right here. That's not too bad. NumPy.load. I need to convert the gas, like the accelerations and the acceleration categories, into this one-hot format. So that's just two categorical is a built-in thing in Keras. If you see it, keras.utils.nputils, you can do it right there. No big deal. And then I set up this little training regimen here. So I said I want to train overall for 1,000 epics. I tried 10,000 before, but I wasn't going to get to that many today. And I have this thing called a mini epic. And so what I'm going to do, or what I have already done, I should say, is I saved the output of the model after every mini epic steps. So I'm just stepping through 100 times, 1,000 divided by 10. That's this. And each time I'm fitting the model. And this is where you can say, oh yeah, when you're doing your fitting, you can specify what the targets are using a dictionary with the layer names. That's where it's super good to have standardized layer names. I fit it and then I save those weights off. That's this business. And, wait, I saved the weights? Oh, I saved the weights and I named the weight file based on the accuracy, right. I was a little silly. Here we go. That's not what I wanted. Here we go. So that's what I've done here. You might notice all these numbers are the same in the first column and second column. I had a bug in my string format at first. Where was it? Where this 2 is right here was actually a 1. So when whatever the first thing was that I passed in, the validation steering loss, the mean squared error, I was actually getting I was putting that in 2 places, which was silly. So I was never using the steering accuracy. I still have the weights, I didn't save that into the file name, which feels silly now. So I was supposed to do that for 100 steps of 10 epics per step. But I started that earlier today, and it was going to take like 8 to 12 hours to do. And I noticed that after like an hour or two, the straight up accuracies weren't really, those were close to 99% of the acceleration or stop or go in reverse that was 99% accuracy. That was super great. Validation was like 60-some%. So I wasn't actually getting that good. Let's see if we can find it. Yeah, here we go. Let's go up here. Just one of the random epics that we happen to be looking at, like this. You can see the validation gas out accuracy, about 61%, whereas the, the regular accuracy was 99% right here. And our mean squared error in the steering, 0.01 on the training, and validation steering main out, 0.03, about 3 times higher, which that's unfortunate. And what I'm doing right now, what's running at this very moment, I'm just recomputing the accuracies and the error at every mini epic step. So every 10 epics. So I've got the weight saved off, so all I need to do, this really shouldn't be called, this should really be called MSE. Mean square, not mean absolute error. I was definitely thinking of old papers I had written. I'm just loading in all those weight files. Well, I'm just getting a list of them all. Then I'm walking through each one. And I'm saying, hey, load the weights. Compute whatever the predictions should be. Just pull out the steering predictions special. And compute out the gasoline prediction special. Hey, Rick. Welcome to the stream tonight. I saw you and Zoltan were doing a lot of great work on the car. So I'm working on the model here. And Rick and Zoltan are actually working on making the car be able to go. And I believe they now have the car. They can control it remotely. But it's not a little RC car. It's like a large, like kids tractor, I guess is the appropriate toy tractor. So, you know, the Power Wheels car size. So we're hoping to maybe collect some data at some point. That might be after the first real race, but that's okay. And I did see they released the actual track that it's going to be on, the layout at least. So as a fallback plan, we could just try to program, oh, go straight, do this, follow the exact layout of the track, which seems silly though. We have steering and remote steering. That's awesome. The steering model, I believe, of this is actually pretty decent. So we might have a steering. We have a machine learning steering. This is almost done computing our weights over time. So what I want to see is I want to then plot. I need to do something temporarily. Since I renamed that was silly. So I just want to plot that over time. And likewise with the accuracy. Just to see. Almost done. This will take another minute. Gosh, making these predictions is what takes all the time. I don't know why that takes so long. But once this is done, it will have read the last weight file as well, which is nice. And I'll want to double check that it's doing the right thing. This is where the model got screwed up before. It was doing steering predictions, but it was computing 3 values for each one as though it was the gas prediction. And it had like negative values out the wazoo, and they didn't sum to 1, so I knew it wasn't just that I'd mixed up the gas and the steering. Ultimately, I think that was because I didn't have the labels correct. I wasn't naming my layers, was the big problem. Info on the race. We need to make an autonomous 90-degree turn on Friday. So we just need to program that we can turn right? That's interesting. Kill switch has to be installed. Yes, it is very important that we install a kill switch on this vehicle. That's not really part of the machine learning model, but that is an important part of making this car so that it does not run amok and start killing people and bring about the end of the human race. That's an important thing to do when you build a self-driving car. You gotta make sure you're not building a killbot. If you are building a killbot, I urge you to reconsider. Okay, what does this actually look like? So this is interesting. So there's one particular epic here, 10 steps in, that we had terrible accuracy. That to me is interesting. I don't know why that would be, but generally it's actually improving. And was this a validation accuracy? No, this is on everything. Right, because I did the still stupid thing. I should have done this differently. I did the stupid thing I just said when I was training, do validation split. So split off 10% of the data. It's going to happen that it's going to split the same 10% each time. But I don't know which 10% that is. There might be a way to figure that out. It would be good to know. Or if I could just give it a seed and make sure I'm doing it the same way each time. But ignoring this huge spike, there's another huge spike, and it's actually improving. But again, this is a lot of this is overtraining, as you saw in the last bit there. Man, I really should have saved that validation accuracy. That's irritating now. And actually, yeah, because we can see right here, this is validation mean squared error as you're going down, and this is actually starting, and it looks like it's actually getting worse at places. It's not changing much, at least. You know, 0.03, 0.32, 2.7, the 3.9. It's actually gotten bigger at the end here. Isaac says he thinks the validation split is taken from the end of the array. I think you're right, but I have shuffle turned on. So which takes precedence, shuffle or validation? Do you shuffle then validate? Or do you do something different? And that's what I don't know. Okay. Well, let's ask Karis what the answer is. Validation, shuffle, sequential model methods, validation, shuffle. Let's see, does validation split randomly choose validation sample issue? And clearly I've looked at this before because I wondered myself. Okay. Does validation split randomly choose? Someone looked at it in here. Do validation split at a particular point. says last 10%. The training data can, the training data can optionally be shuffled. Okay, so I'm looking at the last 10% of the data. So you strip off the last 10%, then you shuffle. Okay, so that tells me what the validation is. That actually saves me a lot of, that can save me a whole lot of effort. Val IDX equals length images divided by 10 times 9, right? Yeah, there we go. Well, yeah, that's fine. We'll do that. Whoa, wasn't in the right mode. Times 9. That will be fine. If it's not perfect, I don't care. So, to save myself some computations, val IDX to the end, and val IDX to the end. And I believe speedx.shape, yeah, it has the number of things is the first one. So now we're dealing with 20,000 data points. Validation data is never shuffled. That's interesting. I find that strange. I wish I could set that and say shuffle everything, but I guess this is an easier way to make sure it's consistent. Not a big deal either way. I think that's all I need to do if I wanted to redo this. So this would only take 1/10 as long as the whole thing. And there's 28 things. The whole thing took how long? 13 minutes. So it should take another minute and a half. Want to redo this right? Let's do that. Let's just compute our validation accuracies with inconsistent numbers of samples. Boo, 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 boo. What is val IDX? That actually sounds correct. What is the... Oh, I know the problem is. Targets. Val IDX to the end, comma, and val IDX to the end, comma. Perfect. And I say perfect, watch it blow up in my face again. Okay, there we go, we're going. Yeah, in about a minute and 18, so 1/10 as long. So that saves me a whole lot of effort. Thank you, Isaac Gerg. Thank you much. So much. I love this progress bar. I can no longer live without progress bars. It's funny, I hear like people who stream video games, they're like modded their game in a fancy way, and they say, oh, I can't live without this mod anymore. Well, I can't live without this Python library, TQDM. Oh my gosh. I would go insane if I did not have that. Alright, and I should just like bookmark this page so I understand how the validation works. I understand it's in the source code, and I can find it in the source code, but reading code is always more difficult in a sense than writing code, especially code someone else wrote. And debugging code is twice as hard as writing code in the first place. So if you've written code that you can just barely understand, by definition, you cannot possibly debug it. You will not be smart enough to debug your own code at that point. But that's just a silly joke. All right, we're almost done with this. Then we can plot proper validation, accuracy, and mean squared error. And I think we're going to see that it's going to be kind of unfortunate. We'll learn that the model has basically overtrained and just learned the terrain of Grand Theft Auto. I mean, that happens sometimes. Oh, it's actually getting worse. Oh, that's funny. So the model is overtrained, and it's overtraining so well that like when you try to generalize it, it just does not work. You still get this huge spike here. Like the model must have been traversing from one local peak to another at this epoch, and something bad happened. Yeah, so our minimum here looks like at number 4. So after about 40 iterations, 40 epochs, it seems to be doing the best. We can zoom in a whole bunch here. Yeah, ever so slightly. What happens when we look at the accuracy? Is the accuracy improved in the gasoline model? Okay, this is interesting. So in terms of the steering, you know, after 40 epochs, it's not getting any better. But in the gasoline model, you can see a general downward trend here. This is actually improving, and interestingly enough, at this point, it's much, much better. Oh, wait, no. Reverse that. This is the accuracy. It's getting worse too. Belay that order, cancel everything. Cancel everything. Also, index 4 is the best accuracy for should we be going straight or backwards or whatever. But it's not spitting out all 0. These values are changing, so it's not like at 67 the whole time or whatever it is. I would probably bias the output to go forward more often than not. But yes, this is also generally getting worse. And again, 40 epochs is maybe where this particular model peaks. It could be that we're in some initial training phase that's terrible. I don't know, maybe not. I kill that. Let's have a look-see at the model itself. At the validation model even. Yeah, there we go. Do that. Okay. And I want steer preds. This has a proper length, right? Length of that. Yeah. Let's say, yeah, valid offset. Val IDX defaults to 0, so if I don't want it, val IDX, there we go. Use val IDX plus. I think that's all I need. So I'll make sure I pull the correct image and the correct other thing. Question from the audience, how am I regularizing? Right now I'm just using the L2 regularization. I just sort of picked a number. I think I had tried 0.01 at first for how much I was regularizing the weights on every layer except the output. But I think that was driving a lot of them to 0 exactly. And so I wasn't getting anywhere. So I settled on sort of this. So maybe I should make it 0.005 on all of them. That's a possibility. That could be part of the regularizing. I think in this case more data is really what you need. Because there's these 20,000 frames or whatever, but it turns out the first 10,000, like the car just goes on this long loop and it does it like 5 times. The conditions are a little different each time because it's like daytime in one and nighttime in another and there's different traffic in the way. So it's not exactly the same, but it is sort of like you're already seeing that scene 5 times, which is kind of interesting. I like that you get the same kind of scene, but not exactly. But then again, maybe not. Okay, let me snag this. Hit point doesn't change. Let me run this. And let me grab this. Move it down. There we go. And now we've already got validation index. Let's see what happens with this. Okay. And again, the red is what our model wants to do. The green is what the actual target is. And you can see where, yeah, although it's like trying to turn right a little more. Wait, is it biased right? It might be biased right. Why not L1 or dropout? I guess I like L2 in general. I like that way I don't have to worry about signs of things, and I think you should punish the model a little bit more. I thought L2 was typically more common. As for why not dropout, I haven't gotten to that yet. That might actually be a good idea of something to try. Yeah, this is kind of strange. What our model is predicting. This might actually even be, there might just be one loop that this car goes around and around and around and around forever and ever. But there's a stop. Like, yeah, there's random times when it's like, yeah, suddenly turn right, suddenly turn left. That could be trouble in the model. Could be trouble. Like in the middle of this, maybe it's trying to get on the center of the road. Yeah, because I mean, it looks like it's most of the time it's actually okay. Let me grab, are these the ones I want? I think that's what I want. Steer shape. Why do I have 2 of these? I no longer remember why I have both of these. Steer preds. I don't think I need to reshape that. And let's say LIDX. Oh, no, that's not what I want. Okay. I need 2 series is what I wanted to plot. There we go. Val IDX. There we go. And blue is the model, green is the actual. Yeah, so our model's not getting up there enough. There's a few instances where the model is just super wrong, but that I can live with. I just truncate that. And then the model spends a lot of time being basically straightforward. Then again, most of this area is straightforward. And trying to turn, here it does some wacky things. That's interesting. Yeah, and I remember seeing that in the beginning. But then again, here is where the model is saying, hey, make a sharp left or whatever this is. And the model is not picking that up. It's doing something very different, actually. That's, I think, what it is. This is the general shape you see in a lot of other areas. And in fact, I suspect that if I say go to length of steer preds right there, you're going to see, well, maybe not. I've seen this kind of shape before, is the point I was getting at, in the actual training data itself. Can you select a different error vector by which to backprop? You want to penalize more of the wrong answers. Different error, so instead of mean squared error, you would, I wonder if you have a bias, since you said you have a loop, essentially the same scene. Yeah, so that's definitely biasing. You're seeing the same scenes. I'm saying, you know, I'm 40 training epochs, and I have 20,000 data points, but really, maybe it's more like 2,000 data points that all happen to, that you see each one 10 times. And it's just slightly different variations each time. Which that could be good for the model to learn. It doesn't key in on exact features. Like if you add a bunch of noise to your own data. I like the idea of adding dropout training. That's a good idea. That might be what we need to do. But I also kind of want to save off this model that we got right now. And say, okay, yeah, that model's decent. And then if we want to add dropout training. One typically does that when you're doing a lot of convolutional stuff, I know. But you could do it anywhere. Let's look up how to do that exactly. I've done it before with various things. Sounds like you sort of have a class imbalance. Oh, there's definitely a class imbalance in the gas acceleration model. It's by and large, most of it is just go straight forward. And there's some scenes, and I've seen in the video where you just need to stop. You're like, you're at a red light, so it's like, stop. And there's only like 1 or 2 instances. Your experience that mean squared error doesn't work for outliers. On that, you are correct, sir. In my ideal world, so the problem, mean squared error, is sort of the standard way to do linear regression, right? And I've got this linear activation unit. So I've got two problems going on. One, I don't actually want to do linear regression because I want to clamp my results at 0 and 1. So I could design my own loss function that's just like mean squared error, or excuse me, my own activation function that's just like linear, but if it's less than 0, I change it to 0, and if it's greater than 1, I change it to 1. So we could do that. That's something we can do. I find that most of the time this doesn't really matter. We happen to fall in that range anyway. The loss, yes, instead of mean squared error, you can use what's called a robust method to handle outliers specifically. Robust linear regression. I think there's a good Wikipedia page for this. I designed a model for this several years ago in a research paper. So essentially, instead of the mean square error, use like the median error. So if you have one outlier, it's like, who cares? It's not the median, it's off all the way in the distance. You sort of ignore it entirely. And you can use things that are more or less between those two things. Where is median? Median. And I use this to detect outliers in travel time data. That worked very well. I'm surprised median doesn't show up on this image. That's interesting. There was a really good book. It had to be from like the 70s or something, but I just checked it out from the library. It worked very well. So robust regression, not something I see in a lot of machine learning models these days. So that would be something super cool to implement. Seems like you can learn the loop list fine, but your error is not getting driven down by the outliers. Need something to penalize the outliers. You want to penalize the outliers more. Interesting. Yeah, I'd have to think about that. It's like I sort of want to ignore, are they outliers or are they edge cases? I guess is the question. It's sort of a philosophical argument. Are they outliers and I don't want my model to be affected by them? That these are things that are wrong that my model should not have to deal with. My model, or like the inputs are bad. The target, whatever the car is actually doing is wrong. Or are they unusual edge cases and so I need to give them more weight that, yes, the input is correct. The model really does need to deal with this. And ultimately, the answer to that is going to be, how do I want to use this model? And in this case, I have a very defined use case of, I need to use this model in a Power Racing Series autonomous car race with a track of where I know what the track's going to look like. So in my ideal universe, I should get a bunch of training on that track, overtrain like crap, and then you have a not very general self-driving car model that only knows how to go around that loop. And then I have class imbalance that I'm not accounting. Yeah, so there's this problem with the acceleration model too. That's definitely a problem as well. I'm not as worried about that problem because that problem can be solved by saying, just always go forward. Just always hit the gas. If you hit something, back up, turn a little bit, hit the gas again. That's honestly not as big a problem to me. And this vehicle just simply doesn't go that fast for it to be like dangerous. I misunderstood what you said. It might be that in chat and live it's hard to gather all these things together. So I apologize if I'm misstating what you mean. If you want to leave like a longer form comment or send me an email to clarify what you mean, I would really appreciate it because it sounds like you know what you're talking about. And very possible that I'm just in the heat of things here sort of missing what you're saying. But I like dropout. I want to try that. Let's do a little bit of that. That's where I was. That might be what we get done tonight. That's okay. That's what happens. Dropout. Special kind of layer. Not a noise layer. Examples, core layer. That should be what it is. Training day is Friday, September 16th. All right, next Friday, not this Friday. And although I'm only streaming one day this week, I will be working on this model pretty much every other night this week. All right, drop out. Oh, it's over here. Use the Control F to search before I even do it. Applies dropout to input. This is probability dropout. Okay. And yep. Let's see if I've actually already. Do I have dropout over here? I do. I've already decided to. I have it here. I just haven't actually used it. I've had it imported this whole time. Okay. This does mean that I will need a new image. Actually, what does it say about dropout here? Dropout, yes. Fraction of the input units to drop. Dropout consists of randomly setting the fraction p of input units to 0 during training time, which helps prevent overfitting. Okay, so it just only happens during training for sure. Like, I understand that you're not supposed to drop out during validation, of course. I just wanted to make sure that that wasn't a setting that I would handle. If you're using something like TensorFlow or Theano more directly, you can have dropout, that's fine. Often you just need to say, this is the probability of dropout during training, and when you actually do your predictions with that, then you just need to pass in probability of dropout is 0. Randomly setting fraction of p to 0, yes. Okay, that we can do. That we can definitely do, no problem. So the thing is, I've only got like 4 layers here, so I think here I want to do that. So drop L3 equals dropout. And how does it work here? Oh, I need to set the probability. So let's say 0.5. And then I need to pass in pool L3. Right? And I can do that. Let's find out. Actually, before I Yeah, it seems to be fine. Drop L3. Okay. And then we put that in here. Drop L3. And we also are going to do that after our first set of dense layers, after they get passed through the activation. So, DD1, for drop D1, oh, drop DED dead, equals dropout of 0.5 of ED1. There we go. Yeah, so we had 64 nodes there. We're going to say, only 32 of those really matter. DED1. I want to be a little... I don't want to add dropout to everything right away. Just at sort of some key places in the model. So for example here, at the sort of, this is like the steering section of the model, where we're only computing some things for steering. DES1. This takes ES1. Oh, and then this needs to take... Hang on. Oh my gosh. Oh, there's something wrong with the model. Look at this. This says S1, which is the direct output of these nodes here. They were never actually going through the activation function. They're getting through, ES1 is getting computed here, but that's not getting passed down to the next layer. Could I try mean absolute error for the error matrix just for kicks? We can absolutely try that. I'm also a big fan of mean absolute error. That's how I've computed a lot of errors. I want to finish this, futzing around with this first. Oh gosh, I can't believe this is misery. Alright, well, might as well fix it now. ES2. I was not using these activation functions when computing my steering. How much? Oh, I have the same problem with the gas. The gas model. One of these days, DEG and EG. Also weight the steering samples by how far they deviate from 0. So it helped to force the learning to focus on them more. Keras has a way to do this. Interesting. So I put more weight on the so I just look at the samples that deviate more, look at them more often. Okay, yeah, I think I've seen something like that. That sounds also like there's some kind of optimizer or training regime where you make your predictions and you look at the samples that you got wrong more often, or the ones you got more wrong you look at more often. I've seen this kind of thing, I've heard of it, but I haven't actually implemented it myself. DEG1, and yeah, same problem down here. Look at this. I only have G2. I'm not actually using EG2, where I put it through a nonlinear activation function. So this whole business was just linear. So it's probably not what was causing my model to be terrible, but I can now blame everything on that. So I'm going to go ahead and blame everything on that for the moment. Alright, there's no reason to train more than like 40 times maybe. Alright, here's what I'm going to do. I'm actually going to nuke my Python session and just make sure to start over. And finding that key error and maybe trying some of these things like mean absolute error instead of mean squared error. That might be what we need. I guess I like mean squared error because I'm so used to using the normal equation to do linear regression. That's why I like mean squared error, because I fully understand what's going on and I can say, yes, that is the optimal solution. Of course, when you're doing like iterative climbing methods, all those kinds of things are out the window, so they don't matter. Is mean absolute error just a thing I can do? I assume it is, but I want to double check. Objectives. Mean absolute error, yes. MA, oh, I can say MAE, nice. MAE, perfect. Okay, we'll do both the unscientific way. Metrics, I want MAE now, not MSE. Okay, and let us do a little bit of this. Yeah, sure, that's fine. Let's do that. Probably should have cleared out my old weights. Weight equals ABS steer direction vector. Interesting. You don't have to learn with them more, just give them, oh, just force them a weight on them and then compute it. Interesting. Okay, I still wanted to see what was going on, how this was going to affect things. Shouldn't take too dang long. Should clear out the old weights that are in truth garbage. Proj, autonomous, there we go. And in fact, for a lot of things, I try to be very careful in how I and I'll do them at the terminal, but for things like this, when it's like, oh, I need to make sure to do this, and then that, and then that, yeah. I'm going to rename this file too. Final bogus. Very, very automated naming scheme here. Isaac's jumping ahead. Oh, I can't. I'm barely keeping up as it is. I can't jump ahead at this point. Weight equals absolute of the steering direction vector. Oh, I see what you're saying. That's interesting. Okay, this model's going, takes 1.5 minutes. Interesting. I guess because I actually have all these extra activations. I wonder if the ELUs are what's taking so long then. Because that adds like 30 to 40 seconds. It was 50 seconds per epoch. That's interesting. I wouldn't have expected that to add that much more, but I guess it's like 6 ELUs per, plus you gotta compute the dropout, decide what to keep, what to drop. Maybe. Steering loss, what is this? The gasoline out accuracy. So it hasn't overtrained yet, of course. It's only at like 54% and not, is it moving up, moving down? Not moving much today, it's moving up ever so slowly. 55, there we go. Probably overtraining as we speak. MAE is slow auto diff. Oh, that makes sense. Because mean squared error, it's very easy to take the derivative of, which is why it works so well in the normal equation. Whereas the mean absolute error has got to be hideously complicated. I gotta take a derivative of an absolute value. That's a function that looks really stupid. Not stupid, but I'm not a fan. Whereas like the mean squared error is nice and convenient, but if you think about absolute value, it's bad. No, whatever. Let me draw a picture for those other viewers that are not as familiar. You got your axes. Your absolute value function looks like this. And you'll notice at this key point, there's no derivative. Because there's this sort of not continuously differentiable. But you can try different things. And with the power of automatic differentiation and what I am almost certain are going to be just approximations to the derivative, you sort of don't have to worry about it. It's going to average out certain changes. So it's not going to be a super big deal. But that's good to know that MAE is what's slowing this down. Alright, so it finished one, 53% accuracy there, mean absolute error, steering, validation, mean absolute error. Oh, okay, validation accuracy of gas is 53. What is actual gas accuracy? 55. Okay, so it's not overtraining too bad in that. After one epoch. Again, one epoch. One epoch, but 5 looks at the similar loop. So not so bad. Their steering, mean absolute error, 0.15. Validation steering, mean absolute error, 0.1142. So that's not too bad either. It happens to be better, in fact. One of those things. Of course, this is going to take a while to go now because it's taking the 98% or whatever. So I'm going to let it train just a little bit longer. Actually, that's good enough. Just a little bit longer, and it's done. That's one of those things. Okay, let's... I want to not compute everything. Here we go. Do some of this. Validation index. Compute the validation index. There we go. There we go. And I gotta compute my get points first, or set that function anyway. Things are all in different orders. This isn't really a script on the right. It's a... Not sure this bought us much. Well, we didn't train hardly at all, so we don't know how bad it is. That's the nature of the business, I think. Yeah, and our model isn't doing anything yet fancy for steering. It's just barely getting off of drive straight. So that's to be expected. We haven't learned anything. We haven't learned anything yet. Yeah, you see we're listing slightly to the left, which, like, for this particular loop, I guess maybe it's a counterclockwise loop or whatever, that happens to be reasonably accurate. Although, like, clearly we need to drive left or right at different points here, and the model is just not picking that up. It's just always a little to the left. It's probably basically straight, but it's getting a little confused at times. That's not too bad, though. So this will just take more training, is what that's going to take. Let me just go ahead. You know, what are the other options here? What other things did it have that were good in terms of objectives that were obviously available? Mean absolute percentage error. That I haven't seen before. Squared logarithmic error. So differences that are small matter more than differences that are large. So I believe this will weight your outliers less. But, again, it's the philosophical argument of, are they outliers or edge cases? If they're edge cases, then they matter. You just go back to MSE. Yeah, I'm with you on this one. I'm just going to go back to MSE. It's a little faster. It's statistically responsible in the ideal world. I'm just going to make sure I rebuild the model so I don't keep any of those weights around. I don't want a model where I've developed weights in multiple ways. That's a recipe for trouble. Alright, let's see how this is then. Okay, big money, big money, big money. I guess I don't really need TQDM here because I already have the Keras verbose mode turned on. Verbose mode, also awesome. I've said that before. I will say it again. I will continue to say it. Verbose mode is excellent. I love verbose mode in Keras. List, this is so good. This is like all the information I want. I can't imagine working without this. Oh, look at that. That's already better. Already better. Still taking like 80 seconds. I don't think that the model has kept whatever old garbage it has, so it might just be the ELU that's adding some of this. This isn't taking as long. Not too bad. Not too terrible. We are making some progress. I guess maybe the dropouts slow us down. Well, let's ask the internet. Whoa, okay, sure. Training slow? Question mark. Slow training of LSTM? No. TensorFlow is 4x slower than Theano. Well, yeah, if you're not using GPU. Much slower than lasagna. Well, that's not really what I want. And no information. There's no edge cases or outliers per se. You have to account for class imbalance. Do that is force large errors in the early epochs to minimize their error. Ah, I see. I think I starting to understand what you're getting at, Isaac. I think I understand. It's one of those things I'll have to sit down and clarify what the heck am I doing? Am I doing this the right way? Am I on a CPU or GPU? I am on a GPU. However, it is an old consumer-grade GPU from like 4 years ago. So I've only got 2 gigs of video memory. It's an old GeForce. It's a little warm right now. It's definitely to the point where I can't run things. I can't run things like 24 hours a day. If I'm using it hardcore for like 4 hours, it will want to break. One of those things that I consider, like, oh, I could upgrade that, or I could upgrade my whole computer, or I don't know. I bought a new hard drive, so it might just be that I get a new graphics card in a few months, maybe around Black Friday or something. this year I'll look into that. We'll see. It's just not that big a deal to me. This is probably one of the biggest models that I've had to work with. Especially, it's the biggest model on the stream that I've had to work with. And I try to do most of the training off stream, but the reality of the situation is that some of it has to occur on stream because that's part of machine learning. A lot of like waiting for code to run, your training to go, and while that's going, you're trying to do something else, and think, all right, well, what else can I do to this? And the training is iterative, but the process of developing the training is also iterative. Is I think one of the key things to learn about machine learning. That I'm going to try this and learn, oh, that's wrong. I'm going to make a small mistake, and then I have to go back and fix that. And he said, oh, I need to develop a good visualization, go fiddle around with that. All right, I'm going to interrupt the model here because I think that's probably boring to people right now. Let us... IDX. Yes, okay, that's all good. Everything is good. Everything is fine. We're all fine here. You know what? I should have just plotted first. I didn't do the plotting that I wanted to do. Here we go. This is what I wanted. Could Atom be the reason of the sluggishness? Maybe. I admit I haven't looked into what exactly the Atom optimizer is doing. I know I've had better luck with like getting decent results using that optimizer than just using stochastic gradient descent or RMS prop. But that could be. It could be that it takes longer than others. Yes, and I was using Atom before the dropout in the ALU. What am I? I'm over here. No, that's not where I am. I'm right here. Yeah, so the model's still starting to learn a couple different things, but it's not doing a particularly great job right now. So it's just sort of like, go straight here, whereas the real is like, turn left here. And then it drops down to a little bit different. This is some interesting streakiness. So that's just weird. It's like you start turning this way and then you slowly turn that way. Which I guess that's like real behavior. That's just strange. Somebody's asking in the chat room, what's going on here? We're doing machine learning to try to build a self-driving car model. That's what we're doing. This image should make things relatively clear. The red is what the model is predicting. The green is what the actual target is. This footage is from Grand Theft Auto 5. You'll notice this model is just sort of predicting always list to the left, because this model has only gotten a tiny bit of training done, because we're trying to fix some errors in the model. We should be getting to... eventually, the model should be doing wacky things. But it's not. Yeah, and you notice the footage in this, like, the car does some strange things in strange places. Atom is quite touchy. Is it? I'm not that familiar with Atom. I'm open to other optimizers. I like SGD because I fully understand SGD. Atom is something that I'll use. I'm willing to use things I don't have 100% understanding of. I don't like it, but I'll do it. Super good that the references are right here. You know what? Let's go to the reference. Yeah, so we're going to show a research paper on stream right now. I'm sure that'll attract lots and lots of viewers. Method for stochastic optimization. Oh, only from 2014. Wow, that's impressive. Actually, I just want to look at the abstract right now. First order gradient-based optimization stochastic objective function based on adaptive methods of lower order moments. Straightforward to implement, computationally efficient, it's great in all these different ways, yada yada yada. Large numbers of data or parameters, appropriate for non-stationary objectives. Problems with very noisy or sparse gradients. Hyperparameters have intuitive interpretations, yada yada yada. We also analyze theoretical convergence properties, the algorithm, empirical results say that it's great. Alright, well didn't tell me really what it was. Isaac says, usually try SGD and try to overfit the data first. If you can't get that to work, I have no business doing ML. So if I can't overfit the data, then I have no business doing ML. Well, maybe. It depends how much predictive power actually exists. And a lot of popular machine learning benchmarks and things like that, you have tons of data to work with. So it's like, who cares? Well, you can definitely model things. But in certain problems, you might only have 100 data points, and 10 features. And you're just not going to be able to you won't be able to overfit in a sense, but you'll not be able to get like 100% accuracy. There's just not enough information there in the data. And sometimes on those problems, you're not trying to get 100% accuracy. Let's just make both of those, that's fine. Let's try SGD. Let's see if that's faster. Just for the giggles. You know what, I'll even not... Let me make the model function, there we go. Me too, 8 to 9 hours difference. Then you get fancy. Yeah, I was gonna say, start simple, start simple. Like the first stream in this series, I had a simple model for what I was planning to do, and that was all like linear, and it was just super straightforward. It might be that I shouldn't be joining the steering and the acceleration, even though I'm sort of splitting those models at these points. So these weights are part of the steering. They're only going to be affected by steering errors. These weights are part of the gas. They're only going to be affected by the gas errors. But it might just be that these are two rather different things that I shouldn't be I shouldn't be affecting their weights higher than that, more so. Yes, isn't that the default for Atom? I know I futzed around with the defaults. Let's take a look. We want optimizers. Atom optimizer. Atom. Oh, an A to max. Cool. Yeah. Yeah, that's just a default for what those things are. Oh, we're not going to try to read this paper on stream. That's way too boring for all of us to try to do. Oh yeah, here's a basic rundown of what the algorithm is. All right, I lied. Maybe we are. Initialize the vector. Initialize the moment. Another moment. Before we've converged, increment the time step. Get the gradients. Update biased first moment. Take one estimate. All right, yeah, I'll have to sit down and read through the paper. Like, I have a degree in mathematics, but like anytime I see equations, my brain has to like shift into a different mode and fully understand. Yes, there is room for experimentation, but I want to make sure I have a good sense of how to experiment before fiddling around with it. Values might not be the ones from the paper. That's true, they might not be, but I have a suspicion that they are. Or I have a suspicion that it might not matter much. Yeah, 0.01, 0.9, 0.999, 10e negative 8, which is what we got here. 01, 0.9, 0.999. Yep, 1e negative 8. So, all the usual stuff right there. Crap, I didn't see how fast that was on stream. I guess it'll tell me after it finishes this epic. And, well, that's amazingly, I feel like I accomplished nothing, but we fixed up this model a little bit. We might just have to strip separate steering and gas models. That might just be the only thing that makes sense, or at least separate steering and gas models in the sense that even if I train the models at the same time together, I compute entirely separate trees of features on them. I think in that case I'd rather just have two totally distinct models. And I'll load in the data twice and I'll train it twice, and that's fine. Oh, that shut you up? No, that's a good thing to check. Of like, are the defaults recommended? Because you never know. I mean, even if you're a developer and you're very smart, it's very easy to mix something else or be in the wrong decade. I had a professor who used to say. So you put the decimal point in the wrong place. Easy to have a typo doing that. It's easy to just forget exactly where it is. Definitely check the easy to check things first. All right, how long does it take? Still 90 seconds. All right, so that's just how long that is going to take, I guess. All right, well, it is now just about 7 o'clock, and this is just going to train for a little bit. So I think I'm going to let that do that and not worry about it too much. See what happens. Put the dropout on the images to start. I think, did I add one? Did I not add one? I didn't add one. I didn't add one because I was only computing a very small number of kernels. So I wasn't as worried about it, but I guess you're right. I got 5 by 5 times 4, so I'm computing 100 things. So yeah, maybe that is definitely worth doing. And it's definitely more common with dropouts on convolutional outputs, even after the pooling. So I'll look at doing that too. So thanks everyone for coming out tonight. I appreciate the lively discussion going on, and I look forward to learning more that we can learn more from each other. So that's it. Have a good night. Stay safe in the data mines. Take it easy.